Hello everyone, welcome back to my video. My name is Margareth Stevany Sinurat. I'm college student from Mathematics Education Study Program 2019 at State University of Medan. In this video, I will explain about Chapter 12 is History of Mathematics in Europe. The first mathematics resource in Europe based on classical treasures, Europe mathematics came from Thales and Euclid. The Greeks studied, criticized, and spread by Arab Muslims in the early Middle Ages. Then in the 12th and 13th centuries BC was used by Europeans. Algebra emerged from the practice of algebra by abacus, disseminated by its users by Fibonacci and Pacioli. The practice of problem-solving algebra in this tradition developed from Islamic Arab source. The epistemic basis of mathematics as a calculation was formed by the Arab Islamic world. An explanation of these basics became the main motivation of our analysis of the basic concept of Islamic Arabic algebra in the beginning. The second progression of figures in Europe. Around the year 1825, a Persian mathematician named Al-Khwarizmi wrote a book on algebra which, among other things, contains the complete Hindu number system. Later, this book was translated into Latin in the 12th century, and his books were influential in Europe. It was this translation that introduced the Hindu-Arabic number system to Europe. The development of mathematics in Europe in the 13th until 16th century. In the 13th century appeared a figure named Leonardo Fibonacci. Leonardo Fibonacci, or better known as Leonardo da Pisa, was the most talented mathematician in the Middle Ages. It's known in Indian biological system since the 200th century BC. He was the son of a merchant who followed his father to trade to Egypt, Sicily, Greece, and Syria. His greatest work was a book entitled Liber Abaci in 2200. This book deals with problems using Hindu-Arabic symbols, which shows that he was influenced by the algebra of Al-Khwarizmi and Abu Kamil. Liber Abaci focused more on arithmetic than geometry. This book begins with an explanation of 9 Indian numeral symbols by adding 0. Fibonacci also consistently used a flat line minus as a symbol to express division. In this book, Fibonacci used 3 types of fraction, namely ordinary fraction, sexagesimal fraction, and unit fractions. One of the problems in Liber Abaci is how many pairs of rabbits will be born in 1 year. Starting with a pair of rabbits, if it's month, each pair produces a new pair of rabbits, where a new pair of rabbits will produce after the 5th month too. And the second, this problem is known as the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, and etc. His extraordinary talent caused him to be summoned by King Frederick II to take part in a competition in which 3 questions had been prepared by John of Permotiga, and one of them was that x squared plus 5 was a square of a number and x squared minus 5 was also a square of a number, and Fibonacci answered correctly that x has a cos blank square plus 5 This problem is found in the Liber Quadratum book. Besides the Fibonacci also writes identities in the Liber Quadratum book, such as in the 13th century, the universities of Paris, Oxford, Cambridge, Padua, and Naples were found. The university accelerated the spread of knowledge in Europe. This century produced several mathematicians, namely Jordan Saxo, Campanus, Sacrobosco, Roger Bacon, and Nemorarius. At 14th century, the 14th century was a barren period for mathematics. This is the century of the Black Death that wiped out more than 1/3 of the population of Europe. In this century, there was a 100 Years' War with political and economic turmoil in Northern Europe and its peak. Although medieval mathematics was essentially practical, speculative mathematics did not completely disappear. The ideas of scholastic philosophers led to subtle theoretical talk about motion, infinity, and continuity, all of which are central to modern mathematics. At 15th century Renaissance period in history, the 15th century is called the Renaissance era, namely the rebirth of attention to classical Roman and Greek culture and trying to find new values from this culture. With the fall of the Byzantine Empire and the fall of Constantinople to the Turks, refugees poured into Italy. The refugees brought Greek and Arabic knowledge to Europe. Science books translated from Arabic and Greek into Latin began to spread in Europe. This event greatly inspired the rebirth of interest in classical studies in Western Europe. Most of the Greek scientists fled to Italy and brought with them the great classic of Greek science. For the first time, the West has direct contact with the original Greek scientists. Before in the West, classical Greek science was studied through Arabic translation, which often contained many misinterpretations. Like other fields of science, mathematicians are now able to study works of Latin and Greek studies. They translated many Greek mathematics textbooks. Euclid's Book of Greek Elements was also translated. Although in the early Renaissance, mathematics was basically an imitation of ancient times. Math weren't able to get out of Greek knowledge. They brought their knowledge as the practical need for mathematics increases. In the 15th centuries, printing equipment was also found, so that the trade in the science books also developed. Mathematical activities in the 15th century were centered in Italy, in Nuremberg, Vienna, and Prague. Nicholas Cusa became governor of Rome. He wrote several mathematical brochures and updated the calendar. He was also interested in solving square circles and bisecting angles. George von Feuerbach, after finishing studying mathematics in Italy, he lived in Vienna and founded a university in that city. The works of Feuerbach are on astronomy, arithmetic, and compiling sign tables. He directly translated Ptolemaic books from Greek into Latin. In addition, he also translated the works of Apollonius, Heron, and Archimedes from Greek to Latin. Pure-bred student John Muller completed the translation of the Almagest into Latin. John Muller's work entitled The Triangulis Modis was written and published in 1050. The book was about plane trigonometry and spherical trigonometry, written spreadly from astronomy. Muller, also known as Regiomontanus, then settled in Nuremberg, established as observatory in the city. Then he set up a printing press and wrote astronomical brochures. In the book Trigonometry, he wrote 3 conditions to be able to determine the elements of a triangle. For example, determine the elements of a triangle. If one side is specified, the height on that side and the ratio of the other 2 sides. Solving these problems, he still uses rhetorical algebra. He also wrote the tangent function table. French scholar Nicolas wrote arithmetic in 1040. In his writings, he described rational, irrational numbers, the theory of equation, and the positive and negative integer exponent, written in schizopated algebraic form. And Luca Pacioli, an Italian monk, compiled a summary of arithmetic, algebra, geometry at that time in a book entitled Summa. The book describes the algorithm for extracting square roots, commercial arithmetic, bookkeeping, and solving equations using the wrong position method. The algebra he wrote was still schizopated algebra. His abbreviations include P stands for Pew, which means at, N stands for Meno, which means Co stands for cosa, which means an unknown object is used to change x. C stands for censo, used for x squared. Cu stands for try to use for x cubic. Cc is censo, used for x4. AA, the symbols plus and minus were first recognized in the arithmetic publication in Leibniz by Johann Wittmann. However, the use of the symbols has not been used as arithmetic operation to add and subtract. It has only been used to express more and less. The use of the symbol plus and minus symbols as arithmetic operation was carried out by Van der Hoek from the Netherlands. Trade activities in the 15th century also increased the issuance of arithmetic necessary for trade itself. In 1078, an arithmetic book was published with the title Treviso Arithmetic in the city of Treviso, a city on the trade route from Venice to cities in the north. The content of the book on numbers, calculations using numbers related to trading businesses. In Filippo Calandri published a book on arithmetic which became the basis for the method of division known today. The question in the book described the calculation of custom duties on trade in Italy. In other Europe countries also published arithmetic books, among others written by Jacob Koebel in 1014 in Germany, and in England by Robert Ricord with the title The Grown of Artists. And at 16th century, towards algebra with symbols, Robert Ricord wrote works in algebra, geometry, and astronomy. He wrote algebra with the title The Whetstone of the Witch. It was in this book that the symbol equal was first used for similarity as it is used today. Christoph Rudolph wrote a book on algebra with the title diunggah. Michael Stiefel, a German monk, published a book entitled Arithmetical Integral. In that book, he described rational numbers, irrational numbers, arithmetic series, geometric series, binomial coefficients to the 7th power. The book used the symbol plus minus as arithmetic operations and uses letters for the unknown. Algebra using letters. Francois Viateur was born in Fontenay. He was a jurist and member of parliament, but with extraordinary talent used his spare time studying mathematics. Even then, he was seen as the greatest mathematician of 16 BC. He wrote a trigonometry book with the title Canon Mathematics Crucial et Triangula. This book was the first in Europe to systematically solve plane and spherical trigonometry problems. It states cos and q and equal 1, 2, 3 until 9 with cos q. He wrote algebra under the title in Analytical Essays book. He began to compose algebra with letters, vowels for the unknown, and consonants for the specified. For a square is written a quad, a cubic is written a cube. High equation. Descartes wrote algebra under the title De Numerosa Potestatum Resolution. In the book, he described the approximation of the roots of high-degree equations successfully. The fifth method was used in Europe until 1680. History records attempt to solve these high-level equations in general. Descartes also gave a solution to the quadratic equation. Euler tried to solve an equation to the power of 5. Next, Perufini, an Italian physicist, tried to solve the fifth power equation in 1085. Proved that solving the equation was impossible, and that Niels Henrik Abel, a Norwegian mathematician, proved it was impossible to determine the roots of an equation to the power of 5 or more expressed by the equation coefficients. Ending the 6th century, Simon Stevany from the Netherlands wrote arithmetic. He was the first expert to write about decimal fraction. He also wrote about statistics and hydrostatics. Nicolaus Copernicus of Poland. He wrote a theory about the universe, which was completed but published only in 1543 after his death. He wrote trigonometric figures. George Joachim Rheticus, a student of Copernicus from Germany for 12 years, he compiled a trigonometric table on the 6 trigonometric functions in second intervals. The first scholar, Rheticus, defined trigonometric function expressed by the side of a right triangle. Table Rheticus was published by a German priest who was interested in mathematics, namely Bartholomew Pittacus. It can be concluded that at the end of the 16th century, the development of mathematics had already laid the foundation for its further rapid development. In the 17th century, algebra has begun to be written with symbols using letters. Number calculations are standard with the Hindu-Arabic number system. Decimal fractions have been arranged. The theory of high degree equation has been solved in a certain form. Negative numbers have been included in the number system. Trigonometric functions have been systematically arranged together with the tables of trigonometric function. Next, mathematician in Europe in the 13th until 16th century. There are René Descartes, was born in La Haye, France. He is also known as Renatus Cartesius in Latin literature for his work on creating the Cartesian coordinate system. René Descartes lived in an age of change, just like the world today too. The period when Descartes lived was a time when he new ideas about science, mathematics, philosophy, and literature were created by intellectual giants such as Newton, Galileo, Fermat, and Shakespeare. In his dream, he saw how algebra could be applied to geometry. This talk opened up an entirely new field of mathematics now called analytical geometry, which has become one of the most widely used mathematics by scientists to study natural phenomena. Next, Isaac Newton. In the field of mathematics, Newton, together with the work of Gottfried Leibniz, which was done separately, Newton developed integral calculus. He also succeeded in elaborating the binomial theory, developed the Newton's method for approximating the zero value of a function, and contributing to the study of power series. Next, there are Leonhard Euler. Leonhard Euler is a mathematician who produced the most discoveries of all time. Next, there are Carl Friedrich Gauss. Carl Friedrich Gauss considers himself the prince of mathematics and sees mathematics as the queen of science. One of his work is that he published the book Disquisitiones Arithmeticae, which is the most influential number theory of all time. Next, Gottfried Wilhelm Leibniz. He was a universal genius and expert in law, religion, philosophy, literature, politics, geology, history, and mathematics. Next, Augustin Louis Cauchy. During his career, he served as a professor at the École Polytechnique, Sorbonne, and Collège de France. One of his work was that Cauchy developed Euler's formula for plane geometry by relating the sum of angles' surface vertices of a polyhedron. S plus 2 equal M plus V. Next, Fibonacci. He published the book Liber Abaci using Hindu-Arabic numerals. I think that's all from me that I can explain on the topic of Europe mathematics development. Please forgive me if I had mistake in my explanation in this video. I hope I will be better in the next chapter. If you have criticism or suggestion, you can write them in the comment column. Hopefully this explanation video is useful for you, and don't forget to share this video with your friends and social media too. And turn on the notification bell to get the latest on topic learning the history of mathematics. Thank you guys. See you next time.